Yeah, so I'll get started. Hi, I'm the other instructor in this course. I typically teach about 4 lectures on linguistic phenomena and how they're handled. This year, since Graham will be away next week, we decided to put it at this point in the course. So this is the first of the 4 lectures on like things that languages do and how people deal with them, right? One of the interesting things about language technologies is that people sometimes fight about whether computer science is really a science or not, right? Or it's just engineering. The nice thing about language technologies is that studying languages is science, because that's something that was around before computers. And so figuring out how to handle languages with computers and trying to understand the weird, complicated things they do, that's definitely science. So far, we've been mostly treating words as these little atomic units that are each discrete and individual. You can just deal with them as just these strings that don't change. And that you get away with that in English pretty easily, because English happens to be one of the 2 least inflecting major languages in the world. Chinese is the other one, Mandarin. And the great thing is that people who know Mandarin and English know these 2 wildly different languages, neither of which do hardly any inflecting. And they say, well, this other stuff is like not real. And I kind of had that feeling. I lived in Germany for a while, and when I first learned German, it's like they can't really be serious about all this complicated stuff they do, but it is. They really don't understand you if you don't inflect things right, and it's really, really complicated. German is one of the harder scenarios. So we're going to look at starting at kind of the simplest level and working up on these phenomena that languages exhibit and that we have to deal with. All right, slide change. So we're going to look at 2 main classes of approaches to word segmentation and morphology. There are linguistic approaches that worry about segmenting the text into words and segmenting the segments of words in ways that make sense with the meanings and the grammar, because the way you segment the words affects how they interact with the grammar, which we'll see a lot of today. And so we're worried about how things affect meaning and how they interact with grammars. For a lot of work, that's not as important, depending on what you're trying to do. If you're not dealing with grammars of the language, or you're not worrying about trying to get at detailed semantics of sentences, that might be more work than you want to do and might not be necessary. And so we're also going to look at technological approaches that don't worry about like what the right way of segmenting a word is, but just like do it a way that works the best for the technology you're in. And so we'll see kind of both these approaches. And we will look at first some phenomena and then talk about how they're handled. And if at any point I say something really mysterious, that there's like some term we didn't define or something, please raise your hand or say in the chat. Your friends will think you're brave and smart to ask. So first of all, what's a word? Which is one like kind of thing. It seems like a dumb question. You start to think about it. For English and other major languages, you say, well, it's the things in the dictionary, right? But like the dictionaries didn't like fall from the sky. Like people built the dictionaries, right? So the people who make dictionaries are called lexicographers. And the question is, how do lexicographers decide what to put in the dictionary? What counts as a word and what doesn't? You also might think, for English and European languages, oh, it's the things in between spaces. Which is great if someone just decided back when they started writing where to put the spaces, you're all set. But some languages don't use spaces, and actually in those languages, like in Chinese and Japanese, there's sometimes fights between native speakers about how you actually segment things into words. They might not agree on every case because they don't have the helpful spaces to tell you what someone else decided. And what linguists kind of think about is it's like the smallest unit that you can say in isolation. So like you can say the word unimpressively, and you can say impress, but unless you're talking about morphology, you wouldn't say un in English, or iv or li. But the root part of this somewhat complicated word, impress, you can say by itself, and it has a meaning, and it can be used in the grammar in a reasonable way. And so that's kind of the intuition they use. But things get tricky, right? Usually in language, what happens is there's some base case that's like easy and obvious. And then you actually start working with real text, and all kinds of horrible things come up. And it's like, oh God, how do we do this? And so with defining something as a word, the first thing you run into are contractions, which show up all the time. So if you get the word didn't in English, is that one word or two? And if it's two words, do you divide it at the apostrophe, or do you take an apostrophe T as a word instead of did? Similarly with would have, even better, there's these things people say that they don't normally write, like gonna, right? So as a native speaker of American English, I say gonna, I'm gonna go to the store. And the funny thing is, as a kid, I would never have thought about this, except I know, teacher says you can't write that down in your papers, going to. And these are called reductions. And people do this in speech all the time in, I think, every language. And the problem is it causes trouble for analysis, because gonna is really a verb and the infinitive marker in English. And they're like run together, and they're like two different things. And like, people don't care. They just keep talking. And the funny thing that people don't realize, like even native speakers don't realize this unless they've like studied it. It only happens sometimes. So I'm saying I'm going to the store. No one would ever say I'm gonna the store. Okay, that's crazy and not right. But nobody knows why, right? But it's because going to is part of actually a complicated verb pattern in English, whereas going to the store, to is actually working as a preposition, and so you can't say gonna, and no one would ever think of doing that, right? And there's a lot of words like this, like there's even a saying, shoulda, woulda, coulda. If someone is like, kind of saying that they were gonna do something, didn't get around to it, so yeah, shoulda, woulda, coulda, right? And people say shoulda and woulda and coulda. And these are all kind of weird cases, like, does that count as one word or two or what? People swear that some people say I'm really sure I never do that. But I think like on the West Coast or something, that's I'm gonna. It's even more contracted. And then you get other cases that are tricky in writing even, like when you get compounding where you combine two nouns. Blackboard is written as one word, but school board is written as two words. Why? Well, because that's how they do it. A lot of things that happen in language is just what people do. And there's kind of a grassroots community decision as to what the right thing to do is. And when you're in school, your friends make fun of you if you do it the wrong way. And so everyone starts doing it the same way. It turns out high school kids being mean has actually a function, which is it makes everybody talk the same. Because if you say something different, your friends make fun of you. And similarly, like baseball versus golf ball. Baseball is one word, golf ball is two. Why? Who knows? There actually are sometimes reasons, but nobody knows the reasons or thinks about them. And so it kind of doesn't matter that there's a reason behind there. You just kind of have to know how people write things. And sometimes it's even different between different dialects, even in English. The most interesting case in English is the apostrophe S. So this is called a clitic. And that's something that attaches to a word, but really isn't part of the word. It has a broader effect. So the possessive in English, the normal way to say the person who left's hat is the person who left's hat. But the apostrophe S doesn't modify left. It modifies the whole phrase. And that seems a little bit unusual, but everyone would say Jim and Greg's apartment. If Jim and Greg are roommates, you wouldn't say Jim's and Greg's apartment or Jim and Greg apartment. You say Jim and Greg's apartment, and everyone knows what you mean, and it's fine. But that apostrophe S actually applies to the whole phrase and not just the one word, which is weird. And so you might, when you're segmenting words, you might want to break that off as a separate thing that's kind of like word-like, but not really. And then in writing, people do all kinds of terrible things like abbreviations and all capital acronyms that probably count as words, but need to be dealt with somehow. So it gets a little complicated even at this level. And in case anyone thinks it's simple, there is a 1,000-page book. I found that the paperback's available for $50 now. So this slide's a little old, yeah. But there's actually a 1,000-page book you can buy where lexicographers figure out how you define words, right? For other languages too, right? Not just English. So you don't have to buy the book, but it's good to know that it's someone can write a 1,000-page book and actually sell it on the topic of what is a word. For people who are doing linguistics. Since we do language technologies, a lot of times we have an easy way out of really hard problems. So for us, the thing that makes your system work is the right thing to do. And you can argue with a linguist at a party about what you're doing, and have a lovely discussion. But if the way you're handling words works for your system, that's great. But part of that is that if you're using more than one component, you have to be sure that they expect the words to be handled the same way, right? So if something is tokenized with one thing, and then you try to run something that expects a different tokenization, you're going to get some higher error rate because some of the tokens don't match right. Yeah. So any questions about any of that? Okay. So we'll talk about tokenization first. And so there are some Asian languages where everybody understands that you want to do something. You can actually handle Mandarin. This is Mandarin. You can actually handle Mandarin just at the character level, but actually works better typically if you segment it into words. And you can segment on punctuation, which does a little bit, but a lot of segmentation you just have to figure out. I'm told that this is about the Libyan National Transitional Council from a few years ago. I do not read Mandarin myself. But there are also European languages that cause trouble in this way too. So I lived in Germany for a while, and there are these famous noun-noun compounds that Americans think are just insane. Gesundheitsversicherungsgesellschaften is a perfectly normal German word. But see, it's not that hard, because really what's going on is you have to imagine the hyphens. So in English, you say health insurance companies, and there's 3 nouns in a row. And one thing that Germanic languages do, but not all European languages, but like Germanic languages, will string together a bunch of nouns and say, okay, this whole big thing, that counts as a noun. It's a new noun I made. And in English, you have to figure out what to group together. In German, you have to figure out how to split the thing apart, right? So it's kind of a dual problem. Because really what you'd like to have like spaces and parentheses or something, but people don't do that. That'd be much easier. Right, and yeah, so, and other European languages do this too. So in Spanish, they have these clitic pronouns. So in the same way the apostrophe S attaches in English, the pronouns will attach to a verb in Spanish. And so dármelo is to give me it. Me is me and lo is it. And so you get this longer word that's got actually kind of several words in it. Not as impressive as German, but it does happen. And I mentioned already the apostrophe S thing. I sure hope the correct slides are being shared. Someone asked on chat if the correct slides are being shared. The slides on the website as of yesterday should be the same ones I'm using now. Do the people online see something different? Oh, they only see the first slide. Oh, that's too bad. I've heard of this happening before. I gotcha. Okay. So if you're showing, sometimes it helps to share your screens to the PowerPoint. Yeah. Let's see. I was looking for here. Okay. Yes. Yeah, yeah. Anything special or just? You want to pick desktop. I see desktop. Yeah. Okay. Sometimes it's working, sometimes it doesn't. I have a funny feeling that this is going to be weird for them too. I might have to just have it full screen. And now these things. Does that for the folks online? Do you see one slide or two at once? It's correct. It's correct now. Okay, good. Thank you. One thing here, I've lost the chat window. So bring that up. I'll go back to that in a second. Guys, please tell me if the slides never change. Let's see. Okay. Okay. They've still got just the one slide. Okay, good. Okay, yes. So fortunately, you should be able to pick it up from here. Just to show you the lovely German thing for those who didn't see it online. I think it's very impressive. And these things are formed just on, as you talk, right? They're not in the dictionary. You just have to know that there's going to be a couple of nouns plugged together, sometimes with an extra S just to make things tricky. Okay, so so the problem with tokenization, uh, well, we actually you worked with this already, I think, in problem in your homework too, where you had used the spacey tokenizer to tokenize things, right? But just in case you didn't think about it, all kinds of complicated little things can happen. This is an example of the Stanford tokenizer. And so, if the input is like, Dr. Smith said tokenization in English is, quote, harder than you've thought, unquote. When in New York, he paid $12 a day for lunch and wondered what it would be like to work at AT&T or Google Inc., right? So the tricky thing, there's a number of tricky things that happen. We've talked about a little bit, and basically, for technological things, as long as it's consistent, it's going to probably be fine. But in the case of the Stanford tokenizer, in addition to adding parts of speech, which we'll get to shortly, they've decided that for contractions that they'll split off the apostrophe VE as one thing. Another tricky thing that happens is how you deal with numbers and money and things like that. And if people are doing speech recognition, this produces a whole bunch of new problems because people don't speak the pronunciation, they don't speak capital letters, and they say things like $12, but they write $12, and so things get turned backwards. And so you have a whole bunch of like special rules you have to fix all that kind of stuff. Also, in this particular case, one of the many weird formal writing rules of English says that you don't have two periods in a row at the end of a sentence. So Google Inc. period, that period is both part of the abbreviation and the end of the sentence. And so in this tokenizer, they actually fantasize an extra period. So the tokenizer actually gives you an end of sentence period in addition to the abbreviation period. Just an example of complicated fiddly details that go on. And so typically, what people have done in the past for languages that have word spaces, they'll use the spaces and punctuation plus a whole bunch of special purpose rules that fix the things like the double punctuation thing. And spacey is, I think, a rule-based tokenizer, in fact, that you use. For Chinese and languages like that, traditionally, they've used really big dictionaries of Chinese words plus punctuation and rules. There's always a word they didn't think of, which causes problems. And so we'll see later today what Sentence Piece and some other software use to do Chinese, where they actually learn to use subword segmentation from data instead of having to compile some giant dictionary. We'll see that a little later. And when you're doing like academic contests and things, people almost always split up the sentences for you. But in real world things, if you actually get texts from the web or real people, you also have this step of actually deciding where the sentences are, right? Because you don't want to just deal with the whole web page at once, or whatever you're processing. And in English, again, this period is very difficult for sentence segmentation too. It could be a sentence boundary, it could be part of an abbreviation, could be part of a number, things like that. And so typically what they'll do is they'll tokenize first and then have rules that decide, is this actually the end of a sentence or not? And again, it's a rule-based thing. Yeah. So that's all I'm going to say about tokenization, unless there are questions. Okay. So in terms of subword analysis of these words that are more complicated than we typically think, we're going to start by looking at some linguistic approaches. And again, these are mostly for systems where you either want to do a grammatical analysis or you want to deal with meanings, and you really need to have kind of the right sub-segments and not just ones that are handy for processing. And so morphology actually comes from the Greek word for shape. The Greeks invented a lot of Western science, and linguistics was one of them. And so a lot of the language is from Greek. And typically there's three main kinds of morphology people look at. So there's derivational morphology, where you can make a new word from an old word. So there's the word grace, which is kind of basic meaning is kind of like elegance in motion. And you can turn a noun like grace into an adjective by saying graceful. And so that's, something that exhibits the property of having grace. And then you can add other affixes to do things like make the opposite of something. So you can say ungraceful, which means, the opposite of graceful. And you can see that already we're talking about meaning. These linguistic bits are associated with meanings and with agreement with grammar, as well as just being, helpful subparts. The funny thing about derivational morphology is that there's a lot of patterns to it, but it's not something you can always do on the fly. And we'll see that later. And the meanings are sometimes not 100% obvious. Whereas inflectional morphology is kind of the thing that happens all the time. And basically, the individual words and their forms will interact with the grammar of the language. And so inflectional morphology, the inflected forms add some kind of information, which is pretty regular. So for example, plurality and tense are things that many languages will mark on verbs. So if you say this student walks, it's singular and it's in the present tense. If you say these students walk, it's still present tense, but it's plural, right? And so both the noun and the verb change form to match each other, and they have to agree, or people think you're speaking weird, or you're a baby. And then you can make the past tense, these students walked, where the verb form changes, but the noun stays the same. And which things agree with what and how they change is one of the parts of the grammar of the language. In different languages, different things have to agree in different ways. And then the other main thing is compounding, where you make a new word by combining a couple old words. And we already talked about this a little bit. You may or may not have a space in there, but when you compound them in English, you often get rid of the space. So, so these morphemes are the minimum bits that a linguist would be happy breaking a word into. And it's not just about frequency, because like TH is really frequent in English as a pair of letters. It expresses a single sound, but TH doesn't mean anything. It doesn't carry any meaning. Whereas, apple and walk, both are words that carry some specific, fairly complex meaning. And then they have affixes that can attach to them that will carry little bits of extra information like plurality or gender or tense on a verb. So un is a negative prefix in English, s is a plural suffix. And these things can be added in the front and the back or in the middle. And so the generic term for all of those together is affixes or affixes. And there's a list of these for any given language that's not going to change very easily. And when we work with languages at a linguistic level, we typically use rule-based systems or learned rules from data. And so you can just think of it as, instead of thinking of it as just like a general rule-based system with thousands of rules in it, because all the words, there's a few subclasses of words, and all the words in a particular subclass or part of speech act the same way. We use a lexicon to store them in. So a lexicon is really a big database of words and whatever information is specific to the word. It'll show what kind of morphological patterns they are in. It will show how they interact with the grammar, and they'll often include the kinds of meanings they can express. If you have a system that has to handle meaning, the example I always use is like talking to a robot, right? We actually have faculty here who work on talking to robots, or robots talking to you. And if you're going to talk, if you're translating things or you're doing information search, you can mostly ignore meanings actually and just look at statistical co-occurrences and things like that. But if you say to the robot, bring me the coffee cup from the kitchen, it's got to know what a kitchen is at some level. It's got to be able to recognize a coffee cup. And it's got to know what bringing is, right? And so if you're talking to robots, you have to really deal with meaning, which people often avoid if they can because it's hard and you have to do a lot of work to make it work at all. But for some applications, you really need meaning. And so if you've got an application with meaning, then your lexicon will have connections from things like coffee cup, to some information the robot can use to recognize, and warn it not to crush it with a 1,000,000-pound grip or something. Yeah. So the lexicon is where you store all this, and these subclasses of words are typically called parts of speech, which we'll get to in a minute. Now, because different languages behave wildly differently with regard to how these systems work, linguists have divided the languages up into large types of languages, and this is called language typology. And if you're going to start working with a new language, it's really helpful to figure out. The first thing you figure out is what general class of language it is. And so, in going from this morphologically simplest, more complex, there's isolating, fusional, agglutinative, polysynthetic, and others. And so look at each of these quickly, relatively quick. So for isolating languages, Mandarin is a famous example. English is also an example of a language that's almost isolating. It's got, verbs have 5 forms, nouns have 2. That's almost 1. Right. So when you're working with English, a lot of systems have just ignored morphology. Just we'll put just all 5 forms of verb in. They're different things. But in many languages, you just can't do that because there's 1,000 forms of a verb. So Chinese is the other the other main example of an isolating language. Although there's a little bit of morphology, maybe, depending on how you think about things, even though people often think that Mandarin doesn't have any morphology at all. So there are some things that look like maybe they're suffixes. So I can't pronounce Mandarin at all because there are these tone things I can't do. Although it's great. I read a Mandarin thing to a colleague of mine who was Chinese one time. She said, "You got the tones wrong." But yeah, but you know what I meant then. If I got the tones wrong, you know what I was saying. So men seems to be something to do with people, right? So you've got we, you, they, comrades, all end in the syllable men. Was that close? Anyone? Okay. And there are also derivations, kind of. So a doer of art is an artist, I am told. And so the Chinese word for artist is kind of art doer, maybe. But really, compounding is the main thing that happens in Chinese, where maybe 80% of Chinese words are compounds of simpler words. And one of the things that happens in every language is when you compound things, you kind of add meaning. That's why they exist as compound words, right? So blackboard is a compound in English. It's not any board that's black, right? A blackboard is one of these things. And you know that they're made out of slate and you need chalk to write on them, and magic markers are a bad idea. So it's got some extra meaning, but it does come from the idea of a blackboard. And so all these compounds kind of add a little bit extra meaning, and that's why they become their own word. So isolating languages are easy to deal with morphologically. The funny thing is that these more complicated languages, agglutinative languages, are also pretty easy to deal with. So one of the standard examples for this is Swahili. So we have a sentence like mtu alilala. Does anyone here speak Swahili? Okay, good. So in that case, my pronunciation is perfect. So the person slept. It actually was a fad for a while in the US to study Swahili. It's from East Africa. Mtu alilala is the person slept. Mtu atalala is the person will sleep. And so the li versus the ta in the verb tell you if it's past or future. Whereas watu walilala is the people slept. And so you pluralize it by changing the and the to wa. And watu watalala is the people will sleep. And I'm told this is all real Swahili. Someone could have a big practical joke on a lot of people, but I'm pretty sure this is true. So so the interesting thing about languages like this, which is a large fraction of all the languages in the world, is that each of these affixes have a very specific meaning that doesn't change, right? So the li versus ta is, past versus future, and the versus wa is singular versus plural. That happens across a lot of words, but like many European languages, it has genders or noun classes, except there's 9 of them. So each noun class will have its own variation on what these affixes are, but they're these little atomic things that each carry one bit of information. It's very clean and handy, and it's really nice to work with morphologically. And so that's the basic idea behind agglutinative languages. Then if you take this kind of to the extreme, actually, Kamal Aflazer, who's on our faculty, actually came up with this example of Turkish because he's Turkish. It's not a normal Turkish word, but Turks can supposedly understand it just fine. So you can have this one word that means behaving as if you were among those whom we were not able to civilize. Okay, and so basically, it's taking the root word for civilized and adding a whole bunch of suffixes to it. So there's a suffix for to become something, which is not unusual. There's a suffix for causing something, a suffix for not being able to do things. There's past, there's plural, etc. And so you add all these suffixes to this word, and you get this, complicated meaning in one word. Now, most Turkish words have like 3 morphemes, but Turkish people would look at this and understand it. They'd say that's a good trick, but they'd understand it. If you take this to even, and in English this happens too with Latin-derived words sometimes, right? So opera and opus both come from the Latin word for work, and operate is this English word that back in the Middle Ages, people really thought Latin was way cool, and so a lot of Latin words got into English and other European languages. So operate is kind of a base word and a root word in English, and then you can add these suffixes in English which do a similar kind of thing, and so you can get operationalization, which is a perfectly fine English word that some of you may have even used in recent times, which behaves similarly, not quite as outrageous, but the same idea. And then you go to the real extreme. Yupik is a Native American language from Alaska, and you get these polysynthetic languages where you can basically produce an entire sentence as one word. What would be a sentence in English is one giant word. And the difference between that and agglutinative is basically you can include nouns and verbs in the same word. So if you want to say in Yupik, you want to say, he had not yet said again that he was going to go hunt reindeer. That's one word. Reindeer hunt, future say, negate, again, and third singular indicative, right? And so there are all these suffixes. You take the word for reindeer, you append hunt to it, and then you add all these suffixes to produce the rest of the meaning. And so many Yupik sentences are 1 or 2 words. And so the big problem in Yupik is actually doing the morphology. The grammar is not that hard. And that's kind of the extreme case. And there's a significant number of languages around the world that do that. It's not at all unusual. The really weird, unusual kind of morphology is what the other European languages do. And so if you know any French, Spanish, German, Italian, Swedish, the other European languages mostly, except for English, they have this odd inflection thing where they have paradigms. And if you've ever, who's actually studied some European language other than English? Just so I have any idea. A few people. Yeah, people online can't really raise their hand. So if you learn any other European languages, you spend a lot of time looking at tables like this, because in the European languages, they've fused together multiple different pieces of information in one morpheme. And so in Spanish, which I know a little of, amar is to love something. Amo is I love in the present. Amamos is we love in the present. And then you get things like amare, amaria, amarias. And so one ending tells you the tense and aspect of the verb, whether it's singular, plural, and whether it's first or second or third person. And you basically just have to learn these. And there'll be sets of verbs that use different sets of affixes, and those are called the paradigms. And there's some small number of classes in European languages, like 3 or 4, that share all these suffixes. And it's kind of funny, there's all these languages that do the same weird thing that like nobody else does. Uh, and like, how did that happen? And I think it's a small aside, but I think it's really worth knowing. So who's ever heard of Indo-European? Oh, cool, more than one, good. So there's this really cool thing that about 6,000 years ago, about where Ukraine is actually, if you've heard of Ukraine, about where Ukraine is, there are these guys living out in the steppe, and they had this explosive expansion. Given that they didn't have airplanes, right? So starting 4,000 years ago, somewhere around Ukraine, they started spreading out, and they spread out like crazy. And by 500 BC, they had replaced almost all of the native European languages. They had spread all through the northern part of the Middle East and all the way to India. The Sanskrit speakers in India came from the same explosion. And there's kind of a big mystery as to how this happened. Were these just like really nice guys and everyone loved them? For a while. So one funny thing is that this place where these started is actually where the horse was first domesticated. And so if you're the only guys with horses, you get around a lot better than other people. And they start like, you'll sell them horses, but you got the horses first. And so that's part of the reason for this gigantic explosion probably. But the funny thing is, just because you have horses, like, why do other people just let you take over, right? And at first people thought, well, maybe they're like great warrior, blah blah blah, but there's like not big battles or anything. They don't find lots of spearheads and stuff. The kind of weird, sad thing that would be very poignant for people nowadays. This is also the time and place where smallpox entered the human race. And so probably, well, it's not sure, but one theory, these guys ride up on their horses, say, hey, how is everyone? And everyone dies. And they don't know why, because smallpox kills like 90% of the people when you don't have any immunity. And so there's all these like empty villages, like, oh, where everyone went, unhappily, the same thing happened in North America when the Europeans showed up. They said, hey, would you like to buy a spearhead? And everyone dies. So like the Pittsburgh area was relatively empty when the colonists showed up. There were a few settlements up and down the river. It's like, well, gee, this is nice. Why isn't anyone living here? Well, they all died. Anyhow, this huge explosion is why these languages are all kind of similar. And they know that they started in one place. One other really interesting thing about historical linguistics, back before they had cars and trains, you couldn't stay talking the same way as someone else if you didn't live next door, right? Languages naturally evolve. And if you spread out, your friends 100 miles away are going to start talking differently than you. And so after a couple thousand years, you have a new language. And so they know that these languages all had to start in one place. It's not some kind of funny coincidence or, people sending telegrams back and forth. Right. And so I think that's really interesting. And one thing I just learned recently, so before I get to that. So one kind of cool thing about this is that this was actually figured out by a German guy when the British invaded India. When the British were busy trying to conquer India, this German guy noticed that there are all these Sanskrit words that look a lot like Latin and Greek. And it's like, oh crap, this is like related to Latin and Greek. And the funny thing is like the Europeans thought Latin and Greek were these like very, very fancy, wonderful languages, better than our little, German or English. And the English were apparently not happy at all to find out that the Indians they were trying to conquer actually had a language related to them. So like, oh, they're cousins, oh crap, But the Germans said, oh, this is pretty funny, haha, England. And so this, was developed further, and it's just absolutely true. You can just really tell that Sanskrit is connected to other languages. And because there are so many modern languages that are descended from this language, you can actually work backwards. And so people have spent 170 years, something, way over 150 years thinking about this. A lot of people got PhDs on this, and they've figured out how all these languages develop from one another based on sound changes, right? So the Germanic languages are all pretty similar. And so at some point, there were a bunch of guys, turns out probably in southern Sweden, hanging out together, speaking Proto-German, and then they spread out. There's Proto-Celtic, Proto-Romanic, and so on. And so these different subsets, you kind of work backwards, and you can come up with a reasonable reconstruction of what these guys were saying in the Ukraine 6,000 years ago. So that's kind of fun. And one thing that's really interesting to me, I just found out a few years ago, there's actually one word in Mandarin. So if you look, the very eastern tip of this whole thing, these guys were like touching China. And it turns out there's this word in English that's still used and still used in many languages for fermented honey called mead. So you can actually get mead some places. And apparently there's a word for sweet or honey in Chinese, which is mi. Right? And it's not, I think it's not 100% sure. This might be the one word in Mandarin that they actually got from these guys way out west. So that's kind of fun. Anyhow, one last bit of historical linguistics. There's this question about why English is so weird, right? So all these European languages have this like complicated, unusual thing that they all do. It's because they're all from the same language originally. But why does English like have almost no inflection? So this is something I don't really understand because Britain is cold and wet, but people kept invading Britain and taking over. So first, like the Celts invaded Britain and replaced whoever was there before them. Nobody knows. Maybe the Picts, or maybe the Picts were another kind of Celt. No one knows. They fight about it. But so the Celts invaded maybe 800 BC when the Indo-European languages moved in. And then the Romans invaded in 40 AD and brought in Latin, which was a Romance Indo-European languages, different from the Celtic languages. And then the Romans left in 410, and the funny thing is they have an actual date from the Roman Empire ended in England, because basically the Romans in England said, help, the Anglo-Saxons are invading, and Rome was being invaded right at the time, and they wrote back and said, gee, sorry to hear, let us know how it goes. And like, send the army, like, we're busy. And so they said, well, okay, fine, get your damn tax collectors out. And so they threw out all the Roman tax collectors in 410 AD, and that was the end. So the Anglo-Saxons move in and they fight. And then like 300 years later, the Vikings show up and they're even tougher and like they fight. And the interesting thing is that because you've got North Germans and West Germans living next door to each other, and apparently it was not as violent as people make it out to be. But because these guys living right next to each other, they can understand what each other are saying, but they've got different inflections. So it's like, well, I know you're saying spear, but you're saying it funny, right? And they intermarry, and their kids say, I don't know this inflection crap, and they stop using them. And so one current theory about what happened to our inflections is it was so confusing combining Viking and Anglo-Saxon that they just gave up. And then later the French invaded, and then the English started invading everybody, and that's how US got here, and they even invaded India and China. So a lot of invading going on. Anyhow, back to patterns of languages. So that's the story of English, which is good to know if you go to a party. So there are other kinds of inflection that are even more kind of unusual and complicated. So the Semitic languages, like in North Africa and the Middle East, have this interesting kind of morphology called root and pattern, where, for example, in Arabic, most root words consist of 3 consonants that have some real abstract meaning, like to read. And then you put different vowels in to give different words related to reading. So kitab is book, katib is a writer, maktab is an office or a desk, maktaba is a library. And so you can see these are all related to the idea of writing, but just to make things difficult, they often don't write the vowels. And so in these languages, you typically write the consonants, and then you have to figure out what the vowels are. And for like children's books, they might add some, they add vowel diacritics for people who are learning it and for children, but like to read grown-up stuff, they don't put most of the vowels in. So these are interesting languages to try to handle, and some of them are relatively important, so people work on them. But it's another example of how different things can be. And there are various other things that can go on. So there can be infixes. Some languages have things like reduplication. So Tagalog, which is a major language in the Philippines, uses reduplication a lot of times, where whatever a suffix is, you double it to do something. Rather than adding some actual morpheme, you double a morpheme. So sulat is to write, susulat is future writing, sumusulat is present writing. And other things can go on. The weird vowel changes in English are a kind of archaic thing that went on in English, where they change vowels. So like tooth, teeth, there are other ones I'm not going to think of. These things were another strange thing that went on. And one thing that people will talk about that you should be aware of are these type token curves. I think I have a chat message here. Let me see if I can. Can I get my cursor back? I've lost my cursor. Here we go. Would it be fair to say that there seem to be a lot of parallels between how species evolve and how languages evolve? Yes. Languages evolve much faster because they can change quicker, but it's a lot of similar things can go on. This actually causes trouble sometimes. So people sometimes, I have to be extremely careful because people always get very upset about everything connected to this. There's an American Black dialect, which is often called African American Vernacular English. And people study it in academia, and it's a real dialect. It's just a different dialect. But many people have very strong feelings about it, on both sides of the racial lines. Someone in the justifying taking it into account in schools referred to it as a genetic dialect of English, and they meant linguistically developed from the same source as American Standard English, but they used the word genetic. I think they got fired. It's like people thought they were saying something racist. But you have to be really, really careful when talking about anything involving American dialects. Yeah. So yeah, there are similarities. Any other questions? Okay. So you probably all know about types and tokens, but the is a type of a word. The occurs in lots of tokens. So there's like a sentence with a couple of thes in it has several tokens of one type of the. And one interesting thing is if you graph the occurrence of different surface forms in a language, you can actually kind of tell what kind of inflection system a language has, because the agglutinative languages, the number of different surface forms just skyrockets when you get more words, because like every verb has 1,000 possible forms. And so as you get more and more text, you just keep getting more surface forms. You just keep seeing lots of new surface forms. Whereas languages like English or Mandarin, it flattens out very quickly. And then the other ones are kind of in between. So this graph just shows that, right? So the ratio of tokens to types can tell you what kind of language it is. So that's everything I'm going to say. If my slide would that. Okay. That's all I'm going to say about morphology, unless questions come up. We now talk about how to process things. So we're going to talk about. Did I skip a slide? It's a little slow. No, interesting. Okay. So we're going to talk about recognizing the words of a language. And you might want to. So the problem of recognizing the words of a language, we're going to see in a minute how to parse the words to actually store the information you get out of the affixes. But first, just recognizing, is it a word or not, right? So in English, it's pretty easy because there's only 5 forms of each verb and so on. But in many other European languages, it's a real question as to whether this is some unusual inflection you never saw before. And so you have to actually do morphological analysis in order to determine, was this a spelling mistake? Was it a spelling mistake, or is this just an inflection of the verb you didn't have in your dictionary? And so to do this, you've got this lexicon of the roots plus a list of the legal affixes in the language. There's a set of rules that tell you whether an affix is a prefix or a suffix, or what other things it can occur with. And then you have a number of spelling rules, because people in almost every language, alphabetic language anyways, people make trouble by having funny spelling conventions that differ from the base forms of things. So for example, in English, if you want to say you have a root form of a word fox and you want to make it a plural, the way linguists will typically indicate that is by having a deep feature like PL, which means this is going to be a plural word. And so you take the root word plus this feature, and you say, okay, well, in English, the way you, and the kids will say this in school too, the way you make a plural in English is to add an S, right? That's what you say. But not really. There's like kind of a two-step process. So in principle, you add this S, but then funny spelling things happen. So with the word fox, you add an S to it. And so the middle line here shows the kind of a string of surface forms of morphemes. And then the spelling rule comes in and says, well, for fox, you have to put an E in because. Whereas for goose, goose is an irregular word. And so you basically store the plural form in the lexicon after marking that it's irregular. And so goose plus plural produces geese, which doesn't change in the surface, right? And this is going to be fairly simple for English nouns. And so you can, so we've all seen finite state automata, I believe, probably in our studies. So, you know, you have these states that you transition between. You have a start state and you have multiple possibly final states. And so for English, you have a bunch of, to add the inflections for English nouns, plural is the only one you really do. And so for regular noun, you basically have a whole set of arcs that will take the various spelling forms of the root words to go from Q0 to Q1 in this state diagram. And then you say, okay, we're going to add an S to get to state 2. And for irregular words, they'll be marked in the lexicon as being irregular. And you'll take the other route that says, okay, it's either an irregular plural noun or it's an irregular single noun. And you get to state Q1 if it's singular and state Q2 if it's plural. And we have the definition of a finite state automaton, which I'm going to kind of assume everyone knows, or ask your friends if you. But even in English, derivations of adjectives can be complicated. So we have things like big, bigger, biggest, happy, happier, happiest, happily, but you can't say bigly unless you're Trump. People like to make fun that he did that one. Unhappy, unhappier, unhappiest, unhappily, and so on. So there's all these prefixes and suffixes you can add to a bunch of different adjectives that adds the same meaning. And so you can have this finite state machine that says I can either add a prefix of un or not. I can have the adjective root, and then I can add er, est, or ly. The problem is that this allows you to say things like unbig or bigly, which normal people don't say. And so it turns out that to do this right gets complicated even in English. And so this is actually not even complete diagram for doing the derivation of English, the morphology of English derivation. And so, for example, there are different, complicated enough I wrote down the example. I hope. Yes, so for example, fossilize versus equal. So equal is like states Q5 and Q6 would be where a word like equal goes, whereas fossil is actually would be states Q0 to Q2, Q0, Q1, Q2. And so there are these adjective and noun and verb classes that native speakers aren't really consciously aware of. And you know, you subtly know if you know how to do it right, which adjective class an adjective is in, and so there's some suffixes you can add or some you can't. And it's just there is no reason; it's just how it's done. And so that's the things that get put in the lexicon are typically things that you can't really derive; you just have to know. And that's what makes working with languages difficult. One of the things is that there are like literally hundreds of thousands of things that you just have to know, which many of us have learned foreign languages, and you realize, you know, there really are 100,000 things you need to learn to know, right? Before you're a fluent speaker of a foreign language, you have learned an awful lot of things. Yeah, and so the other funny thing about derivational morphology is you can't really do it on the fly. And so even though there are these patterns that are true and you can tell what a word fits in, you can't really do it on the fly easily. if you have a lot of influence, you might be able to make a new word. So maybe people will start saying bigly. And if people say bigly enough, then it will be okay, because it's what people do defines what's okay. So instead of just um, knowing whether the word is okay or not, you very typically want to actually analyze it. And so you'd like to know, okay, there's a root word and there's various features, like it's plural or it's past tense or whatever. And so morphological parsing is where you're using a finite state machine to actually break the word up into its component parts and also pull the features out and explicitly represent them, right? So parsing in general is taking the surface form of something and analyzing into the components in some explicit way that you can work with a program easily. So for geese, because it's irregular, just stored in the lexicon says, okay, geese is the plural of goose and it's a noun. But goose can also be a verb. And so goose is actually a word that shows up, but it is the verb and it's a third person singular. Similarly, dog can normally be a noun, which is a singular version of a noun. But dog can also actually be a verb. You can dog somebody. You're not letting them alone because you really want them to do something. And similarly, leaves could either be the plural form of the noun leaf, or it could be the third person singular of the verb leave. And so the output of this thing has to either make choices between ambiguous choices or produce all of them, depending on your application as part of it. And so in order to do this, instead of having a finite state automaton, we have a finite state transducer. And the difference is just that when you transition over an arc, in addition to absorbing one of the characters of the input, you produce a character of the output. Otherwise, it's the same thing. And so what we can do here is we can do morphological parsing using a finite state transducer, where the root words will go in this diagram from state Q0 to Q1, Q2, or Q3. And then if they're nouns, they'll take one of the three paths. And then they'll transition from Q1 to the next state, to the second state in whatever line they're in, adding a feature marker of a plus n. There's different formalisms, but very often people use a plus to add the features to the root word. And so you have the root word plus n, and then either singular or plural. If it's plural, in this notation, it makes a caret mark to indicate a morpheme boundary and a hash mark to indicate a word boundary. And so you take the surface form and you can produce multiple alternatives, each of which have we're going from the deep form to the shallow form. And so we're taking the feature markers and the root words and producing the surface words. And so when it comes out of here, you get kind of the surface forms of the morpheme pieces separated by carets with a hash mark at either side. And then because there are these spelling rules, there's a whole bunch of different spelling rules in English when you add various kinds of endings. The one we're going to look at is Einsertion, which is the middle one in this table. So some words that end in SZ, XCH, or SH, instead of just adding an S, you add an E first. And this happens in speech too. And in speech, you actually change the S to either be an S or a Z sound, depending on the voicing of that preceding sound. So, how do we handle this? So basically, there's a separate finite state machine that will take these caret separated morphemes and do the right thing. So in case of pluralizing, this FST on this slide will add an E in those cases where it should, and not add an E where it shouldn't. And one interesting thing is that one time in a class, a student noticed that state Q5 seemed odd, and none of the faculty could figure out what was going on there. And it looks like for some words, you can have an X followed by an S with no E in between. And at first this seemed like a mistake, but I actually grepped through 100,000 words of English, and there are 3 words that actually do this. They're all compounds. So foxskin, like a foxskin coat, uh, flaxseed oil, which you can get at Whole Foods. Flaxseed is a compound, and the third one is a coxswain, which is a guy that yells at rowers to make them go faster in rowing boats. You can tell that the British had a lot of boats because there are a lot of words in English about boating stuff. So those are like the 3 words that do this. But because there are words like that, you have to have that extra state. And that actually indicates that it has to be a morpheme boundary. That's why there's a caret in there. So if there's a morpheme boundary, you actually don't need the E with the S in at least 3 cases, which shows you, 3 out of 100,000, who cares? Well, if you're only worried about an F1 score, it's fine. But if you're actually trying to do a detailed analysis of a sentence where this happens, it's going to be wrong. And so there's several nice, interesting things about morphology and the finite state approach to it. One of them is that these finite state machines, if you're familiar with finite state machines, they can run in both directions. So once you manage to build a correct finite state machine for a language, you can use it to generate or parse depending on which way you run it. So that's nice. The other really nice thing is you can imagine, there are these various rules for how you combine affixes. There are these various weird spelling rules that are like totally arbitrary and weird and based on the surface form. It's kind of a mess to get all that right, but fortunately, you can compose finite state machines. And so you can basically have one set of finite state machines that has all the lexicon information. You can have another set of finite state machines that knows how to convert features into surface morphemes, and you can have one that another one that understands how to do the spelling changes depending on which letters end up next to each other. And you can compose them all into one giant finite state machine, which then you can run both directions. So, for any given language, with current technology, you basically have to build this by hand. It takes a smart couple of people who know what they're doing a couple of months to do this for a new language. This whole approach is actually called 2-level morphology, with the idea that there's a surface level and a deep level, and the deep level they call the upper side or the underlying form, and the surface form is also called the lower side. And you just have this machine that if you give it something on the one side, it produces the right thing on the other side, and vice versa. And the guy who did this got famous for doing that. Yeah. And so while there's a lot of effort at first to do this, native speakers basically always do this correctly, unlike a lot of other grammatical things. And so the only time anything deviates from this, like native speakers would say, oh, that's a spelling mistake, or they say, oh, he said it wrong. People really do actually follow these very kind of strictly. I had a funny situation in Germany when I lived there, where I had this big long sentence I generated for real in life, and I had one inflection wrong, and the guy I was talking to had no idea what I was saying. And he said, oh, damn English Garden, and he fixed my inflection, and then he understood what I said, right? So like these really matter to people, and like as non-native speakers, it's a little hard to believe that, but it really does. And so the good news is that this is kind of solved, and there's different ways of applying this to the different kinds of languages and the different classes, but basically you can do them all using this kind of technique. Now, I've talked for a while about the linguistic side of things, and so now there's the kind of technological approaches that don't worry too much about the linguistics being correctly represented, but they want to make something simpler work better on lots of data. And one really old idea was called stemming, or a poor man's morphology. And this was mostly used in information retrieval back before, now Google has like what, 100 billion computers or something. But before Google had 100 billion computers and you're trying to do IR on a regular little workstation, when you're doing information retrieval, the endings kind of don't matter too much. If I'm, if I want to look up, singing in many bathtubs, and it finds words with sing and bathtub in it, that's probably going to be a good hit. And so just chopping off the endings in English works pretty well. And so there was this thing called the Porter stemmer. Porter got famous too. And so this guy named Porter came up with a bunch of really simple rules, runs really fast on a really simple machine, and just chops off endings. So he has a whole bunch of rules for how much to chop off in different situations. And you end up with these lists of kind of stems, but not really, because they're just truncated. So like the word no, so knob turns into knob, nobility turns into noble with an I, nobis and noble both become N-O-B-I and N-O-B-L, and so on. And you get these like weird truncated words that aren't really roots, but it's very fast, and for doing something like IR, it worked pretty well. That was the very simple, very old-fashioned approach to this. Much more recently, for neural systems, there's been a fair amount of work on subword segmentation, with the idea that neural systems typically assume a fixed size vocabulary, right? You've got some vocabulary sized vector. It's kind of important that you have a fixed vocabulary, and not too gigantic compared to, like, 100, 500,000 words in English. And the real world actually has a lot of words, and there's actually new words all the time. And so I kept the ones from last year because I thought they were great. The new words last year that were most popular were doom scrolling. That's where you're like going through your phone going, oh my God, oh my God, oh my God. It's various bad things are happening. This year, and quarantine, which is a teenager during lockdown, right? Like they're losing their social development. The new words this year, for example, are shrinkflation. That's when the thing gets smaller instead of being more expensive. And meat space, which I kind of hate, but is, I mean, that's the opposite of virtual, which is awful. Anyhow, there are these new words all the time in every language. And so you have to handle new words somehow. But there's this thing called Zipf's law, which, have we mentioned Zipf's law before? Rare words, well, there's lots of very rare words and a few words that are extremely common. And so even though there's lots and lots of words, the frequent ones are really frequent, and the rare ones are really rare. And the rare words don't have good corpus statistics anyway. So if you're doing things based on corpus statistics, if a word shows up twice, that doesn't do you much good. And so the idea here is we're going to start with some predefined size of vocabulary, look at our corpus, and generate a set of vocabulary that will cover everything we see in the corpus in the most effective way. And so, yeah, I may have said all this. So instead of just using white space or using single characters, we figure out what the most effective way is to use the data. And so we're going to look at byte pair encoding in a little bit of detail. That's kind of one of the most famous ones. The sentence piece of software does all three of these, depending on what you ask for. And all of these things have two parts, like many things do. There's a token learner that takes a raw training corpus and produces a vocabulary of the size you want. And then once you've got that, there's a token segmenter that uses this learned segmentation to actually segment the corpus. So we're going to start with a really simple vocabulary for this example, just the capital and lowercase letters of English. And the algorithm is that you find out which two symbols are most frequently adjacent in the training corpus. So say capital A and capital B. So you take those and you make a new merge symbol AB. And then you go through your corpus and you replace every AB in the corpus with the new symbol. And then you repeat. And so you start out with just the vocabulary of the characters, and you create new vocabulary items until you hit whatever maximum vector size you would like to have. And so this is just the algorithm written as an algorithm. Okay, yeah. Yeah, and so the word addendum confused me for a moment. I thought I jumped to the end. So the BPE can also start with sentence space separated tokens, but it works on Chinese as well without any spaces, obviously. But because it will take care of spaces, they use a special underscore character to represent a space. So a character adjacent to a space counts as two characters in the learning algorithm. So we're going to start with this really boring, simple corpus. The words low, lower, lowest, new, newer, wider, wider, new, occurring so many times, just for an example. So this is your corpus. You're trying to learn the frequency from it. When you add the end of the word tokens, you get a vocabulary consisting of this small set of characters and the underscore character representing a space. So when you look at this corpus, you get 6 occurrences of the word newer and 3 of the word wider. And so the most frequently occurring adjacent characters are E and R. So you create the new character ER, and you replace all occurrences in the corpus with this new character, and you repeat. So you look at the new corpus statistics, and now ER followed by a blank is the most common thing. So that's replaced with a new character, which is different from ER, which is ER blank. And you replace that in the corpus. And then you do the same thing again, and you get NE turning into the new character NE. And you again replace the corpus with that. And you keep going this way. And so you start to actually pull out some of the high frequency words like new and low and newer with a blank after it. And you keep doing this until you get to the point where you've hit your vocabulary size. And once you've done that, this will find all the high frequency words, and it will divide up the low frequency words into higher frequency pieces that they share with other words. And then when you get your test data, the segmented algorithm, once you've got this trained database, you will run each merge greedily in the order they were learned, and you don't worry about the frequencies in the test data because you're not learning them anymore. And so on. And so using this example, newer with a blank after it would become a single token, whereas lower would be 2 tokens, low and ER and a blank at the end. And so it usually includes all the frequent words, and it will often include morphemes because it will find high frequency things like EST and ER. So any questions about any of that? Yeah, so as I said, we're starting with the simplest things. Things will get much more complicated very quickly. So next time we're going to talk about syntax. If I had a little more time, I was tempted to try to start it today, but there's only 5 minutes left, so it's probably not worth it. The one reason why there's so much work on syntax, which we'll see next time and the time after, it's kind of the most complicated thing that really works. The 4th lecture is going to be about stuff that kind of doesn't work but is really cool. It will work someday, and some of it's starting to work a little bit. But like parsing kind of really works, but it's really complicated. So we'll see you all on Tuesday. Thanks.